Okay, we're going to look at today finding inverses of logarithm and exponential functions. Let's start with a quick review. So when we have a log that's to a certain base of a value returns an exponent. And what this function tells us is what power of the base gives us our value. So if this was log base 10 of 100, then our exponent would be 2 because 10 to the second power is 100. And the log function is an inverse of our exponential function. The exponential function is the inverse of our log function. And our exponential function is some base to an exponent equals a value. So if we look at these three parts, base, exponent, value, we can see that our two functions are related. And this becomes a critical piece when we're finding the inverses of either one of our functions. So let's start with this example. I have f of x equals log base 5 of x minus 1 plus 2. So if we're looking for the inverse of this function, the first thing we need to do is we need to rewrite this as a y equals log base 5 x minus 1 plus 2. So now we've got to set up as a y instead of our f of x. It's still the same function. It's just a different format. And I'm going to swap my y and my x values to start the process of finding the inverse. So I'm going to rewrite this as x equals log base 5 y minus 1 plus 2. Now, in order to do an inverse, in order to get rid of this log to solve for my y value, what I need to do is I need to get this log function by itself. And I'm going to do that by subtracting 2 from both sides. And so I end up with, let's change colors here, x minus 2 is equal to log base 5 of y minus 1. So now we're in a more traditional log function format. So this answers the question of what value, when 5 is raised to it, returns the value of y minus 1, and that's x minus 2. So now I have my base, I have my value, I have my exponent. So now I can rewrite this as an exponential function and write it as 5 to my exponent, x minus 2 equals my value, y minus 1. And my last step is simply to bring this 1 over by adding 1 to both sides. So my final solution for my inverse is 5 x minus 2 plus 1 equals y. And there we go. So if f of x equals log base 5 of x minus 1 plus 2, then the inverse, f negative 1 of x, equals 5 x minus 2 plus 1. Okay, so let's take a look at another example, this time finding the inverse of an exponential function. In this case, we have f of x equals e to the 2x minus 3. So first step, I'm going to write this as a y equals e to the 2x minus 3. And then I'm going to swap my y and my x to start the process of finding the inverse. So x equals e to the 2y minus 3. Now my next step is I need to get my inverse, or my exponential function, my e to the 2y here, by itself. So let's add 3 to both sides to get rid of this minus 3. And I have x plus 3 equals e to the 2y. Now, remembering from up top, we looked at this. This is our base. This is our exponent. And this is our value. So I can rewrite this as a log function, log base e of x plus 3 equals our exponent 2y. So let's do that. So we have log base e of x plus 3 equals 2y. So our base, our value, and our exponent. Now, log base e has its own format and special name, and that's natural log. So let's write this as ln of x plus 3 equals 2y. So anytime you see an ln, that's just letting you know it's log base e, natural log. Now our last step is we need to get our y by itself. We need to isolate the y. So we're going to divide both sides by 2. And so I end up with ln of x plus 3, all of that over 2 equals y. And if I want to write this as an inverse function form, f of -1 of x is equal to the ln, natural log, of x plus 3, all of that divided by 2. So be careful that you don't put the line right here and think it's the natural log of x plus 3 divided by 2. It's the natural log of x plus 3, the entire function, divided by 2. And so there's our inverse of our original function, f of x equals e to the 2x minus 3.